generally applicable, but practices may vary based on the context. For example, we want to do frequent deliveries. Yeah, so we want to have an early and often delivery. That's the principle. Now, a Boeing may interpret it once in a 6 months delivery. For them, 6 months is early and often. An e-commerce company may think 6 hours is often for them. So if they want to deliver delivery within 6 hours, that's good. If they are taking more time, then it's good. So again, the interpretation or implementation is a context sensitive. But both of these groups are focusing on frequent deliveries. Depending upon their context, they may change their frequent deliveries. So that's what the principle and the implementation can be seen differently by different organizations and contexts. Now, these principles SAFe has picked up from existing knowledge base. It's not like SAFe has invented them. SAFe has hardly invented anything. What they have done is they have done good integration of existing ideas. So there are like hundreds of management principles. All those principles may not make sense for product development space. So what these guys have done it, they figured it out the one which are more relevant for your work, the value stream network work, and this is a compilation of those 10 principles. Take an economic view. The idea is pretty simple. Do something which makes economic sense. Make decision based on cost benefit. That's a take an economic view. Now, in order to show that idea, they're showing we want to recommend incremental delivery because incremental delivery makes money. That's why we are doing it. It's an economically wise decision to make. Again, you must have been tired of seeing waterfall versus agile or incremental delivery examples. I personally believe they are not comparable. We apply waterfall in a different context, we apply agile in a different context, and we don't necessarily mix those together. We don't have a situation where we can apply both of them and then we are comparing. So since the uniqueness of the situations are different, comparison may not be that much valuable. But in a simple word, we can say, yeah, unnecessary delay of a delivery towards the last cycle of our project is not a good idea. If we can deliver things incrementally, we can first add value to our customers, they can make some money out of it. We can also take frequent feedback, fast feedback. If you are making wrong assumptions, we will come to know. If you are taking a wrong path, we will probably truncate that path early. So the frequent feedbacks help us in optimizing our value delivery. And that's why we are taking incremental delivery approach. That's the SAFe point of view, that it's economical to do incremental delivery rather than doing big batch size delivery towards the end of the project. So we can say, yeah, that's an obvious thing. And now this obvious thing is explained with the help of little bit more mechanics. So I directly go to an activity which we will do together rather than you doing it in a breakout room here, and then we come back to the slides. So here it is saying, let's talk about 3 features. That your backlog has a 3 feature. This is no dependency. Assuming your product is already live, you have 3 features to add. And each feature takes 1 month for your team to deliver. And as soon as you deliver it, it starts making $1,000 per month for you. So assuming you are an e-commerce company, there are features which will increase the sales because the customer will be able to find out the product easily. And these are 3 improvement ideas to improve the sale. And each improvement idea will add $1,000 benefit profit every month as it is getting implemented. That's the situation. Now you can't do all 3 together because you only have one team and your team takes 1 month to deliver one. Yeah, so that's the situation. Now here we are analyzing 2 approaches. One is incremental approach, which means you work on one feature, release it, you work on another feature, release it, and like that. Another is a big batch size development, or you call it waterfallish development, where you work on all 3 features together. You do requirement analysis and design, and once the 3 months gets over, you release it. Yeah. So each feature take 1 month. Either you release 1 month, 1 month, 1 month, or you release at the end of a 3 months, more or less the same thing. Yeah, from a time perspective. Here they are saying, you can assume task switching and all. So I am ignoring it because it makes more complications. So let's see these graph and learn from this particular example. So situation one, when we are doing incremental delivery, I am working on feature A in the month one, I release it. So in a month two, I start making $1,000 from feature A. Here I am developing feature B during that time. I delivered it. So here I still keep making money from feature A, and I start making money from feature B also in my third month. Here I am developing feature C. After this, I will keep making money from A, B, and C. That's a situation which is incremental. Yeah. I hope it is obvious, easy to relate to. Yeah, we can say incrementally, this is how we can make it. This is a month 4 onwards, and then we will continue like this. If I work in a parallel style, the approach second, in that case, I am working on A, B, and C all 3 months, and probably here I deliver it. And afterwards, all these both the values are same. But what I probably miss is earning this money. If I'm working in a big batch size, I will have a loss of 3,000 because the delivery which could have been done in the month 2 and 3 and we could have earned some money, that has been postponed it. So in a simple way, they are trying to show that incremental deliveries are cost benefit deliveries, they are value adding deliveries, and that's why we are promoting incremental deliveries. Yeah. Any question on these graph and calculations before I go back and talk about some theory? Simple, I think it's obvious, but there is a big assumption all three are independent features. There is a big assumption all three can add value. That's a thing. If they are interdependent, then this theory will not work. You need to do something else because the batch size becomes bigger automatically. Yeah. So we understand that, yeah, incremental is good. That's anyway obvious. So now I'm back and I'm saying, yes, that's what is presented in this graph. When we have an incremental delivery, we add money. And the another important thing is it also help us in achieving fast feedback. Yeah. So it is just not about earning money, it is also about stopping, or we call it truncating, the unsuccessful path. If we realize that this thing is not making customer satisfaction, this thing is not liked by the customer, better not to develop this feature further. So we know where we are going wrong also early with the help of incremental deliveries, and that help us in saving cost, because simplicity is the art of maximizing amount of work not done. So we identify what should not be done, yeah, and we maximize that not done part by way of identifying that early. That is also helping us in saving money. So that's another advantage of doing incremental delivery. Yeah, so that's a principle about economics. Now somebody will say, why this line is little less than this? It should be till here. Why it is little less? So Safe is giving one justification for it, and they are saying, the feature value also declines over time. You got a bright idea about these three features, but if you deliver them after 3 months, competitor might have already implemented that idea. Now, this 3 means after, this feature may only give 900, not 1000 to you. So if you capture the value early, at least you exploit the $1,000 value at least for few months before it becomes 900, 800, 700. So if we keep delaying our feature delivery, it is also reducing the potential benefit the feature can give to us, because the time between identification of opportunity and exploiting the opportunity becomes bigger. The opportunity may also decline in their size and nature. So we are saying that overall agile ways of working is good. It helps you in making money early because you are prioritizing and you should be focusing on economic decision making. Now see, in this principle here, they primarily showed us very simple example of incremental and all, but actually this principle is bigger than that. It is just not about incremental delivery. It is about, you have a defect. You want to identify, should we fix this defect or should you release with this defect? Safe will say, how do you take that call? Safe will say, apply economic decision making. What is the cost of consequences of a defect? What is the cost of delaying the release by 1 month? Whichever makes more money, do that. If delaying 1 month harms you more and the impact of a defect doesn't harm you that much, then better you release it with defect. But if releasing doesn't make that much money for you, but if the defect comes in production, it has a lot of loss for you, better not to release and wait for 1 month. So whenever you have a situation, you need to apply economic decision making, and that's the principle saying. Assuming one team is saying, I have two features, I can only do one, our capacity is full. Again, economic decision making. Identify the feature which makes more money, make sure that team works on that and release that. High value item should be released because we are focusing on economic decision making. That's the principle number 1. Any question, comment before I start about system thinking? We'll do fun activity which will ensure that you understand all these principles well. We will do 3 principles at a time.
So I have a question. Like you said that if there are 2 features, if we can do only one feature, and Safe will say that will suggest that do an feature which is more economical, which provides more value. So is that even though the prioritization is less, even then they'll look into it and see how the how about the value, and then they decide, or how is it?
So reverse. The prioritization is done based on value. Yeah. So you can say both will talk about the same thing.
Okay.
We will say the prioritization should consider the economics in place.
Okay.
So we have a technique for doing prioritization, which applies the principle number 1. We'll learn about it tomorrow. We'll call it WSGF. Yeah, there is a video available in our PDF file for people who want to learn about it in advance.
Okay.
It's a little tricky, but we'll explore it tomorrow.
Okay.
Anything else, anyone? Good. Apply system thinking. So again, very basic, easy to understand idea, and it is saying that what is system? So system is a collection of components. Like your software system has back end, front end, middle layer. It's a system. Your agile release train has multiple agile teams. That's also a system. So we are saying that whatever we do is a collection of components. And if we don't have integrated goal, integrated alignment, then these components will become selfish. Somebody will say, I will test when you are finished with development, because that will be easy for me to test, else I have to do a lot of rework. I am optimizing my testing. But that testing delay may not be good for overall value delivery, because you want to get more early feedback, but the person wants to test later because he or she wants to optimize their part of the work. So we can't allow that. We need to have an overall system goal. In the software space, somebody may want to create a great backend, but that is creating a lot of expense to your cloud bill. Yeah? And it is creating expensive solution for you. You won't allow it. You can say, no. Performance is needed, but not beyond this value. And we need to have a performance under this limit. So how do we do that? We need to have a system level goals. So for example, for a product, we should have a system level integration scenarios. We have a system level requirement which talks about user, performance, and cost in all one frame. So this is how we can say that we need to give our teams, our agile release train, total holistic thinking, rather than dividing them and only making them think in their part. Yeah, that's the principle number 2. It is saying apply system thinking. Now, a little bit more in detail. It is saying if you just keep optimizing each and every component, say I make great front end, I make great back end, not necessarily it creates a great product. Maybe front end is working, but the performance is not as per level, or if you are trying to focus too much on performance, the front end may not be good. So we need to see optimum front end, optimum performance as per customer requirement, rather than super performance or a super UI. Yeah? We need to find out optimization at a holistic level. We can't do a local optimization. And we need to, in order to have that, we need to have an overall understanding of system. You can say, guys, do we have an integrated scenario which tells users should be able to key in this much data in this much time and this much should happen till the end, do we have a higher level behavior of the system? If you don't give me a higher level behavior of the system, then we are always focusing on part and pieces which may not create a final optimum system. So in order to understand the whole system, we need to document or identify the overall view, overall high level behavior of the system. We need to understand how the system goals will get achieved with the help of multiple components, front end, back end, or multiple other type of a component. And we understand a one slow component can derail the whole process. If you have a one area in the chain which is not working, then it can derail your whole delivery process. So we need to apply the whole holistic thinking, optimize the whole is the another idea we learned. Now here in the example, they are saying the solution which we are building is also a system. The agile release train which is building is also a system. We should focus on not each team is having high velocity. There is a possibility each agile team or a scrum team, whatever you call it, but from a safe perspective, it has to be called agile team. Each agile team is having high velocity, but at the end, no integration and release can happen. Then we are not applying system thinking. Everybody has a high velocity, but high priority feature is not delivered because it was taking time, dependency was not resolved, so we dropped it. Yeah, but we made our stories go up. Doesn't help. So we need to ensure when we are doing planning, when we are doing continuous reflection or sync up meetings, we apply system thinking. There is a possibility sometime I may need to do a low priority work, my team need to do a low priority work or a less story point work in order to support the overall agile release train. So we need to always focus on train as a goal rather than individual teams as a goal. So whenever we are making decisions, we need to apply holistic thinking, which we are saying apply system thinking, be it a product level decision, be it a team level decisions, interdependency level decision. That's a system thinking. Yeah, we'll do activity in a different way, but that's the overall idea. Optimizing the whole value stream is also a system thinking idea. So it's like this, that you have multiple steps and each steps they takes their own time. Rather than optimizing an individual step, we need to think of the holistically as we learn in our value stream example. That is also an example of system thinking because you are optimizing the whole. So in a simple word, SAFe is saying apply big picture thinking, have a vision, alignment, integrated scenario, integrated performance ideas well understood. Focus on agile release train level goal as a first priority, then team level goals. Ensure that you are doing continuous coordination and collaboration to ensure that we holistically achieve our alignment rather than we just focus on our local goals. That's a system thinking. It's continuously ensuring alignment as a value. I think pretty straightforward. If there is anything, this we will do this attribute behavior in a different way.
Saket,
Yeah, quite, quite.
can you elaborate more on the last one, please? System can evolve no faster than its slowest integration for. Can you please elaborate a bit more?
So in a simple, what it is saying is that in a chain, one weak link can break the whole chain. So it is saying that assuming you have three teams who are working on same feature, and ultimately they are working 30% or like 50% of the features in a way it's distributed from feature. If one team is getting slow, it can derail the whole feature. Because we need to integrate it. So when we are applying system thinking, we are not focusing on only two teams done a great job, but that two teams great job will be zero for me because third team could not do their job. So I need to make sure as a manager, engineer and all, the whole chain is looked rather than I am only focusing on my part of the chain.
Good, good.
Yeah.
Thanks.
Perfect. Again, theoretical stuff in a way, but yeah, practically also we all know all this, but just a language. They that's become sometimes tricky for a safe exam. You know, they use all these language. So you need to be clearly able to pick it up when you are answering the question. Even though we understand it, sometimes we miss the language of.
Was resolved.
Yeah. But our practice test will help you in demystifying those all things.
Sure. Thanks.
Good. Yeah, system thinking is done. There is a book called Around System Thinking. It has a nice example which I want to point out. So, if you want to
முன்னாடி
understand
ஆர்கியூ
a whole
பண்ணிட்டு
problem, like an
இருக்காங்க
elephant.
டிஸ்டர்ப் ஆகுது
So, elephant is like your problem. So, it tells that dividing the elephant doesn't help you in understanding the elephant.
சரி
Because dividing the elephant is not creating a small elephant. So, you can't divide it. You need to solve the whole elephant problem only. That's a system thinking example. I can't necessarily understand the behavior by way of creating a decomposition of problem. Sometimes I need to see the holistic nature of the problem also. That's a system thinking metaphoric explanation. Okay, assume variability preserve option and then we do some activities to understand these three principles. So this one is also pretty simple from a project management perspective. It's all about planning backups, planning contingencies. So what they are saying is we are doing our work, we are doing our planning in the uncertain words. So we can't know the exact requirement in the beginning itself, assuming we are starting a new initiative. We don't know exact the amount of time, technical design it will take in the beginning only. Yeah. So we need to keep some options to change. So if I am designing a new product, I need to keep some design alternative open because I don't have a complete requirement in the beginning. I may get it after few iterations. This is what we really need. So our requirements, our design, our estimation, our commitments, all should have an option for backups. Yeah. We may work with 3 design alternative rather than 1 because after a period of time we will identify which design alternative is making more sense for us. Now, how many alternatives you need, how many options you need, it depends upon amount of uncertainty. If your uncertainties are high, you need to keep more backups. If your uncertainties are less, you probably don't keep any backup. So in general, the SAFE principle 3 is saying that you need to assume some unpredictable event happening. You need to assume something will go differently than you initially planned. And in order to take care of it, you need to have some options, in a way, contingencies. So you might have seen this graphics in the project management word, cone of uncertainty. It is saying, if you are picking up a new product, your uncertainties will be higher initially. As you work, you integrate, you create, demonstrate, you learn about it, your uncertainty will reduce because you will know where you are heading towards. And over a period of time, your uncertainties will start reducing and your option will also start reducing. Yeah? So over a period of time, your options are not necessary to be many, but initially you need to keep more options, and which is very obvious. There is nothing so unique about this principle. We all know it, we all probably practice this. It is just reminder from a SAFE word. Now they remind it by showing you one tool. This tool is called set-based design. Many times in our traditional language, you may call it design alternative analysis, where you keep multiple design options with you before you select the one. When do you do it? When you have more uncertainties. So it is saying it's a set-based design. When you have lots of uncertainties, but you work with only one option, then there is a chances after some time you will start adjusting that option because that option requires change. And the adjustment may goes too much. You may realize this option is not going to work. This design is not suitable for you. So when you have a high uncertainty, that's the important point. Rather than working on one design alternative, you should have a many candidate design. And then maybe after a milestone, you develop, you integrate, you check, and then you identify many of them are not needed. You select a small portion of it based on the customer feedback, based on the performance feedback. And maybe after doing 1 or 2 iteration in our SAFE word, maybe a PIs, you will identify which design option you want to continue with. So when you have a high uncertainties and you don't have a time to do a rework again and again, it is a good idea to keep some options open, work with multiple algorithm or multiple alternative, and based on the feedback, identify the right one which can help you in releasing your product or getting the better customer delivery. And this approach is called set-based design. Again, we can apply it with SAFE, without SAFE also. It's like assume variability preserve option only in the context of design alternatives. Yeah, set-based design. So the next example is the same thing. It is just showing, you apply set-based design on various PI boundaries, you learn, you improve, and you do an adjustment, and based on that, you will find the optimum solution. and that's a good idea of implementing assume variability preserve option. Now we do few activities. Now go ahead, Srinivas first. Yeah.
Yeah, just one step, one slide back.
Yes.
When you do a set-based design, right? Won't this be an expensive solution?
Yes, it is expensive, but we only apply this when this expensive is cheap. Economic decision making.
Okay.
What does that mean? So, for example, what is the cost of not getting the right design after 1 month? Yeah, and what is the cost of working with 3 design during that month? When cost of not getting the right design after 1 month is very high, the delay can cost us very much, then we work with 3 backups. Yeah, when the cost of not having a perfect design and taking another month for finding a perfect design is not that much, we not necessarily work on 3 options. Yeah. So
Okay.
yeah, like in our COVID world, the vaccine time, people were working on multiple candidate vaccines. Why? They could have just worked on one. Each company was investing in many because their cost of delay was very high. They don't want to lose time in getting one path not successful and then doing it again. They are saying, let's try 3 teams, let's try 3 vaccines, whichever will work will good. Yeah, that's a set-based design. But again, you need to do economically. Principle number 1 has to be considered all the time. Yeah, so you need to identify the right economic decisions. Good. So we only apply when the uncertainties are high. You don't just unnecessarily apply set-based design when you can do it without it. Now, we do a quick different conversation or activity here. Now, good news is both of you work on the same Jamboard. Both the teams will work on the same Jamboard, so there is no confusion. Now, based on your understanding, SAFe, Scrum, Waterfall, whatever it is, how do you see these principles are getting implemented? Some examples. So for example, I can show you, take an economic view. I can take the Ramya's example only, where I can say prioritize based on value, yeah, or economics. So that could be one practice which can help us in taking an economic view, or this is what we are doing as a influence from take an economic view. Apply system thinking. Maybe you can say identify integration scenario, integration tests. Yeah, so we have a system thinking applied. Or maybe I can say that have a system level vision for the product rather than only focusing on small area of the product. So that could be an example of applying system thinking. So I ask you to discuss in your group and come up with such kind of example. I give you assume variability preserve option also. Maybe you can say that we keep some contingencies in planning. So that could be also an assume variability preserve option. When we learn about framework in detail, I will keep pointing out to these principles as we go along. But here we can spend some time, maybe 1-2 example can come from your group in each of the areas. The advantage is we get a better understanding of these 3 principles, and it also gives us time to reflect on these 3 principles. Yeah, same Jamboard, 7 minutes, and talking in the room is more important. If you have a bright idea, share it in the room, then paste it rather than only pasting on the board. Okay? Join the breakout rooms.
Hi again.
Hello. Hello.
Okay, so maybe we can go one by one. So first one we can share, take an economic view. So as per you, whatever you think, and then we can paste it. Or we are writing directly.
You can start, Rakesh. Like, what are your thoughts on that?
Yeah. Okay. So for the take an economic view, prioritize based on economics. That is one thing. But like one another thing could be like we can prioritize based on economics, but the data should be available. So we can prioritize only if we know like what is the cost and all. So we should have some provisions for each feature or like whatever what we have. Some cost related indicators should be there so that we can prioritize it. Because for like if we do not know the insights about the cost and cost part, so we cannot prioritize simply. So
You
have some
mean to say
indicators.
that hidden cost?
No. So, like whatever is the cost, some indicator should be there on that work.
Okay.
Suppose A, B, C, three things are there. But until unless we tag the cost part in that, like some indicators are there, then only we can prioritize. So I don't think most of the times in the work we have these indicators available.
Like, it's like cost to, what do you say? Cost versus like the return thing. Return on the
Yeah, it could be in both.
investment.
Yeah, it could be in both way, like investment in development, and second thing is like the return we get, like the what is
Right.
the value.
Right.
Both
Yeah, we
ways.
can mention that like cost to return ratio or like that. Or investment to return ratio. Shall I stick it on there?
And as Saikat said that the cost of delay also can be mentioned here.
Yeah, I think yes.
In economic we can also add like cost of opportunity, like if there is no such product at market, so we can take aggressive decision by overlooking the cost. So like
Yeah, time criticality. I don't know.
first move to get first mover advantage.
Okay, so we have 3 minutes left, 2 more. So is it sufficient for first one until unless we have some more
Yeah.
ideas? Okay, so for system level thinking, identify integration test, system level vision. Yeah, vision should be there. Then I think first we should have the vision, and then we can identify these things. Okay, what else? Any thoughts on the system thinking? I think it is already there, these two.
The vision and objectives are same, or can we mention objective?
Sorry, I didn't get your point.
So vision and objectives are same, right? Or it's different?
Vision is, I think, more broad, and objectives are more like you can say detailed and at the individual level. So vision is something big, and then it is divided into the objectives.
Okay.
That's how I think. It could be different also. Okay. So anything we want to add for system thinking, or we can just think last one. So for last one, I have already one. Mitigation problem with delay. Okay. Again, I can identify last one.
For last one, can we include like change in requirements?
No. Then it
No?
will not be agile. That will not be agile.
No, there we accept changes, right? In even in the development
Yeah,
phase,
yeah.
also we accept changes, right?
Right,
So
right.
it is something we doesn't know whether these changes are coming in or not, right? So will that come there?
Like we can
Okay.
take a buffer for like the defect fixing and as like
Something
Ramya said,
like
like
that. Yeah.
yeah, defect fixing and some variation from original plan.
So I added one foot preserve option is the loosely coupled architecture. Like when we at the team level, we are coding or like developing something. So have the loosely coupled architecture and leave options for the future changes if the approach changes. So rather than focusing on one solution and tightly have the only code based on that single approach only. So leaving some options within the code. So that is the overall idea. Okay. So I think fine. Any last minute thoughts? Okay, so I think we can go to main room then. We are done.
Yeah.
Okay.
Okay, so I think some of you started using safe terms also, but we can ignore. It's not necessary to use safe terms. Yeah, without safe terms also, if we understand the principle, it is enough. So if there was any question, I see mostly in general good understanding of the principle, looking at the stickies. Safe terminology used, not used, both ways okay, no problem. We'll explore about safe terms and things as we go along. But if someone has a specific question in these three principles, looking at this activity and the theory, we can talk about it now. Good. So management principles done. Again, all these principles work together with each other. We want to apply system thinking. We want to assume variability while applying system thinking. We want to take an economic view along with system thinking. Yeah, so all are connected. Yeah, it is nothing like I have a one principle only at a one place. I need to make holistic decision making. If this is done, then I take you to the development style principles more.